Hello YouTube. Alright, doing another video. Didn't really intend to do this as kind of on a whim. I got the chip replacement for upgrading the firmware of the PACE ADS200, and I already started to crack it open, and before I got to the point of actually having it open, I decided why not live stream this just in case anyone is curious. And I was very impressed with PACE. One, got this very quick after calling in about an issue with my auto shutoff not working, and the immediate conclusion was, or I guess the tech person on the phone's immediate thought was, probably needs a firmware update. They sent not only the chip at no charge, they sent the part puller, the little, I forget what this is called, but maybe it is a PLCC extraction tool, but I just know it as kind of a chip puller, which I already had one, but it's nice to not have to look for it because it's not something I really use that often. And I haven't opened this up before, so I'm not really sure if this is going to give me exposure to what I'm looking for. Now, it did not come with any instructions or any link to instructions, or maybe it did and I just didn't look in the box. But I'm pretty sure it just kind of showed up. Alright, so what do we want to use to try to wedge this? We're going to grab some flat bill tweezers. So I did get that the right way. You just pull that front panel out, all your circuitry is exposed, and what we need to replace is right here. Well, you know what? It does say Rev D, not Rev C, so this is an upgrade to this firmware. We're going to use these flat bills to get up in here and wedge that out. And we got glue on this side. And there is a bit of an air gap here. I was talking to the person on the phone and I asked about this, and they said that this was actually flipped around the wrong way. Which I don't know how that could be the case, but maybe. Again, there is an air gap here, and I think before it was touching, but man, that is close. I don't know why they didn't think of doing that any other way. I mean, you see it in other people's videos. And you think, oh man, it looks bad, but you really can't get a feel for how close that is until you see it. And you know, there was kind of excuses made for this, such as, well, you know, we've done it like that for pretty much all their models, and it's always the same way. And it does feel like an excuse that they could have done better, and instead they just say, well, you know, we've always done it that way. Well, if you've always done it that way, you probably should have figured out how by now to not do it that way. But I will say that it does work. It works very well. I have liked using this. It does not perform as well as my Metcal, and I don't own a JBC soldering iron to compare it to that. I know that that's been pretty much the standard, but I mean, a lot of people say that the JBC performs at or equal to, or I don't know if anybody says that it performs better than the Metcal. That frequency driven heat is just very, very fast thermally to kind of ramp up and stay ramped. This really just does not want to come off. I think Dave Jones made a comment about somebody was crimp happy, and although these crimps don't look quite as squeezed to hell and back as the one in his video, I mean, there is some type of bite force that the actual switch mechanism has. It is just incredible. Son of a bitch. Okay, I'm a little pissed by that. Why would it not come off? But yet, okay, Pace. What the fuck? Your joint here shouldn't be stronger than this. I mean, I'm tempted to not take this off. Yeah, that's like, I might stop messing with that. It's not necessary to pull that off. Well, it definitely has much less slack here. That could have been done better. I mean, that's all there is to it. That is not exciting, to say the least. I mean, the fact that this thing is just so stuck on. That makes no sense. And what I'm hoping is that this switch is not damaged now, which again, easy to replace. Not a huge deal, but a company that's been doing this for as many years, I expect better. We're going to quit messing with that. We're going to leave that as is. Obviously, that is going to have to be fixed in order to get our chip in, or to turn it on after we get the chip in. So kind of created a little bit more work for ourselves. But with that connected, we would have never been able to get this face down. So, but this upgrade, other than that issue, is super simple. It is literally pull the chip, pop the new one in. It goes on this way. And instead of using a ground clip, which probably I should, we can simply just, we're going to touch ground, and although I've been fingered all over this, we're just going to get it on in and snatch this sucker out. What the? Not getting under the chip. There we go. Now we're under it. Are we under on the other side? I think we are. And it's not a gentle operation. I mean, it takes some force to get these out, and you can actually see the pins do get a little twisted from that. Now these could obviously be straightened back out. But we're not going to use this chip again unless maybe it can be cleared off using a programmer and then repurposed for something else maybe. And now putting the new chip in, we just probably should watch my own video and make sure that I have that orientation correct. And yes. So we push it all the way down, and now we need to address our issue of our busted connector here. Which I'm an idiot. I was like, I'm going to quit messing with it, but you know what? That is impossible to resolve unless we remove it. And still fooling with it. I mean, this thing is just on there in a ridiculous kind of way. Alright, so what is another thought here? I'm going to try uncurling these edges. I mean, it's nice that it's definitely secured on there, so you're not going to have any chances for a loose connection, but if you didn't want it to be removed, then you should have just soldered it on there. That is ridiculous. Who's this manufacturer of this? Arco Electric in England. So it's switches made in England. That's unusual. I would have thought China, but I'm sure that it probably is decent quality. I mean, these feel kind of flimsy. Although that's actually just the one that I've had to rip at to get it. This one, yeah, that one doesn't rock like that. This one now feels loose. I think Pace may need to figure that out. Let's do a continuity test. I thought this was going to be a short, very simple video. Alright, so we may have just lost our connection here. We're getting continuity that time. Giving it a wiggle to make sure that no matter what, it maintains the connection. Except for when I pull the contact off, or the probe off of the contact pin. Alright. I mean, there may be... Yeah, there may be a position in there where it doesn't get power. Let's go ahead and we're going to take a look at this. And see what it looks like inside of that. I had a pair of pliers over here. Like always, welcome to the Hot Mess Desk, which always seems to allow stuff to disappear. There should be a pair of, again, thought I had everything I needed. Wasn't expecting to need pliers, so I didn't pull them out beforehand. Put those there. And it's just been super busy and haven't had time to go through and do a proper reorganize and get all the crap out of the way. but it's coming. It is needed, and I have to do this about, here we go, about once every 3 to 4 days. It piles up quick. Alright, so what we need to do now is I'm going to try to actually pry this off. I don't want to have to cut because there's very little wiggle room here with this material. So I kind of just want to see if I can get it to slide off. And we're going to go ahead and I hope Pace watches this video and makes some changes to the way that they're doing these things, because this just shouldn't be an issue. All right, it looks like they're using good quality stuff. I mean, these connectors here are certainly quality material. But something in application has failed, because this should be easy to remove. I mean, you don't make it a spade crimp so that you can never take it off. Alright, I felt it pop out. Not quite there yet. I took my snips with me on a job earlier. Otherwise, this would already be cut through. These pliers are crap. Alright, so we're just doing the most fun part of this video here, which is, I don't know why I didn't have this thought earlier. This will make this so much easier. Sometimes you have to use your brain. When you heat an object, it expands, which should allow it to easily. Don't need that much heat. Like always, anything that can go wrong will go wrong on a live stream, and that's how you know that it's live. Okay, well, maybe I did need more heat and shouldn't have turned it down, because obviously whatever plastic they're using here has a fairly high tolerance. And this is annoying. It's something that shouldn't have to be gone through, but it's still a good machine. Like I said, that this should be addressed by Pace. I mean, this should never be an issue. I don't know what's causing those posts to bind on the legs. But they should be able to easily figure that out. I don't know why this one just will not let go. The plastic is not really expanding. Alright, we're going to change tactics yet again. I don't have my snips, but I have these little scissors. Obviously, these aren't ideal for the job. They just were handy and in my eyesight. Okay, so I can see where there's still some of the that binding post was still in there. It was locked onto that. Alright, so now we need to again join these wires and have them on a spade. Amtech flux, and we'll go back to the cheapy iron because this one cannot be used at the moment. And I'm trying to put it up when it needs to go down. Alright, let me see if I can find a spade, because again, I was not expecting to have to do this. But I think we're going to be okay. Didn't have to look hard, and didn't have to look for long. Ooh, but that is not probably going to fit. That's definitely, let me check one more time. I think I found one that will work. Might actually have a couple of options. All right. That ain't gonna work, is it? Well, we might have to go unshielded. Let's see if this slides down on top. Way bigger than what's needed. Let's see if we can pull this one out. So that fits the size of our double. If I was going to take my time and do this, what I may have done would be, in fact, we could still do that. We could just simply splice a tail off of this. Do we have anything of the right? Where did I put the wire? Staring at me. That's not as thick as, there it is, that is thicker. But I don't know if it's as thick as this. Actually, I think it might be. This is actually some stuff I picked up on Amazon. So I was looking for a thicker gauge. I have a thin wire of this, and I've got this. It probably could stand to be a little thicker, but I think just to make things a little easier, we're going to go this route. And for fun, to keep the wires separate, we'll just go with the blue here. And these are silicone wires, high temperature, very easy to strip. I like this stuff a lot. It makes for easy work. We're just going to sit our wire down, and we're going to go ahead and just twist this up a little bit better. Now remember, this wire has a rosin core. It is mildly activated. What's also nice about this is you don't get that shrink away because the silicone can withstand that heat without changing its shape. So you don't end up with more exposed wire than what you originally intended for. Some helping hands would probably be much better here. I think I need to turn the heat up on these. That's a good enough weld. So this is going to be temporary. Actually going to go back through and modify this to be a little bit more the way I want it. But for now, it will get the job done. We need to put a cover over that. We're going to put some heat shrink on it. And then again, this is just one more thing I've got to find that I wasn't expecting to need. And I haven't organized this area yet to have it where it should be. Pace, you owe me a beer for this shit. Right in front of my eyes. When in a pinch and need heat shrink, those of you that have these stores near you, you'll know that packaging. Good old-fashioned Harbor Freight. Looking to see what I've got in this. I probably needed something a little thinner. You know what though, we are going to do this and we'll go with a double. It's already 2 on there. Pull back out the hot air. And we're going to go a little hotter. Make sure we get all the sides. And again, good enough for now. And now that we have this one, I actually now need to go back to my box. Oh, wait a minute. Didn't even realize it, but I had some over here, but I think these are all, yeah, these are the shoes. All right. Yeah, it's still, again, a little wider than it needs to be, but this will be a much better fit. And we should be able to get the wire down in there now. And my crimps for this are in my bag, still in my vehicle, from when I was out on that job earlier. So we're going to Let's use these pliers. Or maybe not. Ugh. I can't grip too hard. This is actually the hand that I broke my knuckle. I'm sure that sounds like a lot of fun. I actually split off a slice of the knuckle like a pizza pie, and it's now got pins and screws in it to hold it all together. Just for the purpose of showing, I think we've got a good enough connection. I would not trust that to hold long term, but I really do not like this connector. Or not the connector, but the actual switch. I mean, it is just some kind of weird. The fact that I have never had a trouble putting these spades on anything, but and there goes all of the insulators, which again I probably should have closed it up and moved it and not had it sitting on the edge. Just had to double check there and make sure I had that on correct. Let's take that back off. I think we're going to have to do this by the numbers. Okay, so good. That did have more slack in it. It was just caught on something. I was about to say, man, I would have put more slack in a lot of these things. The way these cables are managed inside, again, could have been done different. Let's get that top-down view. Why not, right? Alright, so we've got our transformer inside. Oh, here we go. Transformer inside. Connector here, which looks like it's got a ground wire. It's got a wire coming from... Yeah, this is definitely, obviously, I mean, the color coding is significant, or is whatever the word I'm looking for, it goes with ground. I can see it running and connecting down to that. This then also ground loops back to the main power plug there, and then we've got a black wire, which is on our mains, a blue and a white wire, which are more than likely looped into the transformer. Okay, and then I'd have to look on the other side to see what the heck is going where. Our white, black, and I'm sure there's that other black. So this is hitting transformer. This is coming off of somewhere where we have brown and black. And this is part of our fuse, is it? Or is that the ground or the ISB? Which one? This must be the ISB. Yeah, that's the ISB. Ground is just simply attached to those ground wires. So our instant setback wiring are these little guys here, that orange, blue, and black. And we got power, and then this must be coming from the transformer, so this is our transformer line. Alright. I guess we could do this right. I guess hold it all where it needs to be. And we're not going to put all of these in. At this point, we just want to get enough going so that we can actually run the test, because this video took longer than I wanted it to because that cord decided to fall apart. And there's the original. Again, why this was the way it was, I don't know if maybe that particular manufacturer uses a thicker post, which, you know, in theory, that might make it more durable, give a better solid connection, allow for more amps to pass. Obviously, if it was a high amp rating, then it would certainly need to be a thick, good, sturdy post. However, it appears that this just was way too bound to it. The bite force on this clamp was more on this, what do they call the female part of the spade, shovel, whatever you want to call that. Just was, I mean, it was locked on. The only way to get it off was I had to pry these legs up, which would have been exposed or concealed under the plastic if it had not ripped apart. So, an easy upgrade fail, all due to something that shouldn't have even been an issue. Alright, so that is Rev C. Now hopefully I put that PLCC in there correctly. I'm pretty sure I did though, but I didn't double check before I sealed anything up because you get frustrated when bullshit happens. Alright, so lost my whole train of thought here, and I have our iron. My connector end, which this goes on the front. Let's bring this into camera. Come on, you son of a... There we go. I should probably tighten that up some more. Let's not be lazy. We'll make this a good solid connection, at least on these two screws. But I'm not going to put all four in, because if something doesn't go right, then we just have to open it back up. Alright, make sure that this is turned off before we apply power. And then we are going to grab our... We're going to route this off of the top shelf. And we're just going to put... In fact, let's just go ahead and bring this whole setback stand into camera view. And then somewhere around here I put the power cord. Did it fall down? There it is. It just went to the back edge of that top shelf. Alright, so the light is not on, which power switch is off, so it's working as expected there. We need to pick up our soldering iron, get this around the microscope, and back into the stand. And I haven't gone through all the tips yet. I actually want to do another video with just some real practical use of the tips and showing, you know, how they work, which ones I like, which ones I don't, but I haven't gotten there yet. I just had the two pulled out. I think I bought like 20 tips, so I've got pretty much the entire set. And it's turned on, and we're, it says setback. Let's see if we can prop this up. Get enough of an angle on it so that it becomes visible. Alright, so it now reads setback and then goes down a little and then shows setback again and goes down a little bit to okay, yeah, so as it's dropping in temp, it just says that it's on the setback, and it should, I have it set to go down to 150 while it's on the setback, although I just put this new chip in there, so probably, obviously my settings have to hold because it knew to go to 370, which is what I had it, actually that might be their temp that they have it set at too. So if this is just default settings, then it'll probably go down to this 160, 175 I think is their default. So let's see, nope, it goes down to 150. So my settings are actually stored outside of that firmware. It's not on the PLCC. Now the one thing that I don't like is their time limits for the how long before it'll start the setback, how long before it should do the shut off after the setback's engaged, and the lowest you can go to setback is 15 seconds. So you put it into the cradle and then it still makes you wait 15 seconds. The whole purpose of instant setback is instant. Then once it hits 150, I believe it's 10 or 15 minutes is the minimum value you can have that while it's in here just hanging out. And you know, if I'm letting the iron sit for 10 minutes may be okay, but 5 minutes is probably closer to what I would normally do. I don't mind waiting for it to warm up. I don't need it to sit there and just stay at 150 for 10 minutes. But again, I'm not a PhD in thermodynamics, so is it actually worse? If you are somebody that knows about metallurgy and you know that it is worse to let it cool all the way down and then heat it back up versus having it just stay at 150 for a longer period of time, if that is the case, let me know in the comments because I'll be more than happy to change my habits. Just my thought is if I'm not going to use it, then why am I having it on? And 5 minutes it's a long time for it to just sit and do nothing. 10 minutes is even longer, and I mean there's never a 10-minute break where I'm not doing something with this if I didn't need it. If it's sitting 10 minutes and turns off, and on 9 minutes and 59 seconds I was reaching for it, and it now at 10 minutes by the time I pick it up, who cares if I gotta wait an extra 10 seconds, because this thing does ramp up quick. And in fact, I will angle this some more. We're at setback and this is actually 150. If I could invert this, I would. But we're now going up. We are at, I mean, it's already, and the overshoot is less now with this new iteration. I didn't even really see it jump, whereas my previous version did jump. It would go to the 400, and that was just it pumping in power. And I need to put some tin on this tip before I store it for the night. And this is one of their smallest tip packages. If you can see this, I believe this is the one that is specifically for 0402 packages. Let's put that back in. They've also changed the instant setback switch, and notice that we're still, how do I get that glare off? We're still at 370. Like I said, it will have to wait 15 seconds. And again, that was a fairly decent amount of time between the time I set it down in the setback and the time that it actually starts going into setback mode. I think that needs to be adjusted. That setback time should allow you to at least take it down to like 5 seconds. I mean, 5 seconds is a while. It's 1, 2, 3, 4, 5. If I mistakenly put it in its setting for longer than 5 seconds, then 1, I'm an idiot. 2, it was intentional. It should not be 15 seconds to kick in for setback. But I was talking about this switch, and let's take a look at that overshoot. It only overshooted to like 380 something, which there's obviously been some changes made. So they're watching what people are saying, and they're making corrections to that firmware to make it better. It'll be interesting to see how this, in fact, I don't think I have anything heavy ground plane. Well, I've got a PlayStation board, and that's got a massive ground plane to it, so let's just see what happens. And this is not really the best tip for this test, but now again, this particular package is not meant for, or this particular tip is not meant for doing ground planes, but we're going to see what happens. And we will change out the tip and put, and you want to put no pressure at all on this tip. It is so fine point that any amount of pressure when it is hot is going to distort that tip. And you know what? I'm impressed. I can't remember if that was better or worse. I would almost need another one to go side by side. But the fact that this ultra fine point tip is actually soldering this ground plane, and I mean it's a massive ground, because this actually runs the entirety of this board area here. And all this solid green you see, that's all the same ground plane. There's no separation there. And it's getting a little stuck at 370, but it has, and let's see if we clear this away. Yeah, no, that is a solid join. Alright, and let's take the tweezer tool. Now I find that I use this more than I actually use the little silicone handle. Let's put our foot on there. That's what I like to call it. This is the foot. The other thing that Pace does that I really like is there's a crevice in this tip, and I'll have to show it in the microscope, but I'll wait and do that on the actual video of going about through the tips. But there's like this divot inside of it, which is a nice pocket for holding solder. And so once it's filled with solder, it becomes a flush kind of surface, and it creates a cavity that solder kind of stores into, so you have more solder that you can just kind of drag through your joint. And I don't know if they invented that, but I don't know if I've really seen it on any others. Maybe that's a patented thing for them. But this is just murdering this this ground plane. It is dealing out damage by means of solder. I mean, that is, yeah, I couldn't ask for better performance there. And this is like everybody obviously from watching the channel, it's in the banner. PlayStation repair is a big part of what we do. And this ground plane has always been the bane of working on these machines. So at this price point, I mean, this is probably the best iron for buck that you could buy if you're going to be working on PlayStation boards, because it can just dish out the heat that is needed. This is actually, I thought that was just a random piece of solder. That is actually a leg to a capacitor. No wonder it wouldn't melt. And this does do a better job of getting that solder down on that ground plane than the fine tip did, but again, the fine tip is not meant for that. Let's flip this puppy over, and I just want to see what it does to the legs of this HDMI. And how long does it take for the HDMI itself? And I've got my finger on the front edge of this HDMI. I want to see how well that heat. Oh, I can start. Yeah, it's coming through. It's got good. Ooh, ooh, ow, too hot. Ow. Yeah, getting too hot to touch. Oh, ow, 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 ow. Okay. Yes, I was that kid when the mother said, "Don't touch that, it's hot." I touched it. And we are holding temp. Every now and then I watch it dip down to 5 or 3, 52, 50, and then it went 58, 370. So it just, I mean, it stays within 10 to 15 degrees. It never shows an overshoot. But again, you know, did they just change the programming to tell it to, you know, not display a number over what you set it at? And there was that one overshoot in the beginning. It went to like 380 something. But I mean, this since then, it has not read past 370. So let's do the next test. I bought one of these a long time ago, and the freaking thing read temperatures backwards. I shit you not, it read the temperatures in reverse. It would start at room temperature. I bet you I do not have I do not have D batteries, or not D, that was a D cell, never mind. I do not have a D battery at the moment, so I have set my constant power supply, or my bench power supply, uniform, universal, whatever they call it. Which one is negative? I always forget this. I want to say the big fatty. Let's just test it real quick. Easier to do this than try to fumble with the wires. I always forget which is which. Alright, so negative is tiny. Alright, so we're reading 24 degrees. Whether or not that's accurate, I think the room should be closer to probably like, I don't know, maybe it is 24. It should be about, let's take a look. It should be about 74 in here. I'm just checking Google's conversion. It is 24.1. That's 75.38. So that's pretty close. That is probably a correct temperature. Let's get this cleaned up. Put some fresh solder on it. And I got my window in the way. And you can't see this at all. Being careful to not burn my cord here. Alright, so this reads 370. It did, I mean, we're reading 372, 73. I feel like it might be maybe a degree higher in Fahrenheit conversion of what it started out baseline Celsius. So it looks like, though, we're within 1 to 3 degrees of accuracy. It's reading 370 constant. There's never a change, never a flicker. So I think they added into the firmware some kind of fuzzy logic to tell it, hey, you know, don't overshoot unless you're really, really certain about it. At least in terms of the display, because this is getting some more kind of fluctuation. Well, now we're at 369, 370. I mean, it's within 1 to 3 degrees accurate. So, and right now we're reading both are equal, 370. It's most accurate soldering iron that I've owned. So I can't complain. I mean, that's impressively accurate. And I just put it all over that little copper, and we lost about 20 degrees. And I mean, it was pretty. I don't have a wet sponge right now to do the dab here, but we're still not back at 370 or 364. And I mean, again, this may be this, because this is not, you know, legit FG100. This is the cheap knockoff. I've thought about buying one of the legit ones, but I doubt their performance is good enough to justify a $200–300 price point. I don't know what the hell it's reading now, though. It says 300. Now, I gotta say, my solder does not look as tasty as it normally looks. Let's try a fresh coat of solder and see what that does. We're getting such great readings, and then now, I don't know how long these are good for, but I would think more than what I've used it. Reading 360 across the board. Let's let it cool all the way down. And we're going to warm it up, or we're going to put it on the contact there. Ooh, that is still hot. Maybe that was this, because now it's reading that it was colder in here than it was when we started. Okay, it's climbing back. No, it's going to sit around 20 degrees C, isn't it? Alright, so I'm starting to think it's this. I may need to change that reader out, which really sucks because that means those do not last long at all. But to test this, I'm going to put that up, and it is now in the instant setback. It has not started to set back yet because the instant does not mean instant by any means. Alright, but it is setting back now. Our temp is dropping here. I'm going to spin that like that so we can try to get some of that wire out of the line of fire here. And we're going to go ahead and pull it back up. We were in the kind of low mid 200s. We're at 370 now. Well, we still got that 10-degree plus miss, but I really think that that might be this test line, that it just fails after very little use. Putting some downward pressure on it. And we're at 362, 63, 61, 62, teeter-tottering back and forth. This is where a good quality one kind of makes the difference. If you need accurate, reliable results, I think it's probably worth spending the money. But for me, this seems to be accurate enough. I think if I change out these little sensor wire here, that we'll probably get another couple of readings with accuracy, and then it will go to shit again. So I think that part of it, and let's go ahead and we're going to let this set back, and then we will, before we close this video up, we're going to turn this off so that I can show that different switch mechanism, because it used to just be like a little leaf spring switch, and you would put it in and it would just kick that switch, kind of like depress it. Now it uses a ball switch, which actually it's kind of nice. I didn't like it when I first saw it. I thought that it was going to become, and it may over time become, a little bit too sensitive, where maybe it starts to wear down and it doesn't get a good contact. Because it doesn't have a lot of movement to it. But what it does do is it gives a very flush design. There's no chance for that piece of metal that used to kind of protrude out to get off alignment and maybe become a catching hazard versus the switch that it's intended to be. So potato, potato, tomato, tomato. You like it, you hate it, you love it, you don't. Turning off that external power. Okay, now that's weird. That is, it came out of setback there. It's never done that before. But that could be an issue with that wire that I have in there. Maybe it got a little wonky with all the moving around, and basically like kind of let itself turn off and turn back on, which would have instantly gone into temperature mode. And we can just shut this off. But I want to allow it to cool down a little bit. Plus, and we'll use the little guy because him I can snatch off with my fingers. I meant to do this before. We should be tinning this tip before we put it away. This is not the right way to do this, but it will work without having to take it off and pull it out of Setback. So I want to make sure that Setback is working. And we have just about got to a temperature where it no longer wants to melt solder. So we're now at 150 and we are going to switch this puppy off. Alright, and it's still probably too hot to touch, so learn my lesson once. Sometimes I don't learn it till the second time, but this time I'm not going to burn myself. As you can see, Pace is really good about putting these little built-in cubby holes, and then this, I'm assuming, goes there. And of course our soldering iron, and I like the grip, tip to grip, whatever you want to. It's nice. It's got just the amount of softness. Dave Jones made his gripe about this in the back. I think they may have changed this a little. They definitely changed that grommet inside. So I mean, it feels secure to me. I don't think that it lacks any strain relief, but if you take a quick look at this, and if you go back and you watch his video, well, you can't really see it now, but they've, in fact, that might be part of the change. They've added like this, and then the grommet inside, I think it came out more last time, but it seems to, when you screw it down, it creates a pretty good amount of pressure, and that pressure causes that that grommet to expand, which then makes it tighten down and bite onto that wire. And that wire, maybe it does move a little bit. But, I mean, I'm having to really push it in to get that. So, in my opinion, I think that its strain relief is okay. Could it be better? Yes, but it's good enough. I will agree with him that I think this kind of dangles on your arm a little bit. They probably could have made this a little, sorry, it's not in camera. It gets on your arm a little bit. It might have needed to be a little bit longer, but then, you know, you start messing with clearances, which is a whole nother thing. So, you know, having it dangle. One thing I would really like to see is if manufacturers would make, and I've got a 3D printer, maybe I just need to make my own, is some type of kind of like overhead, you know, pull the wire up and out of the way. But it's a nicety. It's not a necessity. So not something that has to be done. All right, so you can actually start to see it, but we're going to go ahead and we are going to, one, disconnect power because we don't want that wire to shake loose inside of there. And we're going to pull this scope over and we're going to get these tips off so that we don't bust them up. And see if we can get, oh yeah, that'll do it. Alright, so we got our scope on. We're going to go to scope only. And there's our ball switch valve. Let's see if we can show it. Oh, so not actually a ball. It just uses, it is still a contact switch, or that, I mean, they're all contact switches, but it's still kind of like a leaf spring, but it uses this now round ball. And so when this comes and dips in, it's a very smooth, there's no opportunity for it to catch or bind, and it will just roll in and depress and hit that switch. So actually now looking at this under the microscope, I can see how that is a vast improvement over previous. That roundness will fix any catching issues, but it's still that easy to press contact, and there's our switch. One thing I don't think was a very bright idea is this. Maybe it can be tuned up. Oh, look at this. Okay, that is, I guess it's effective, but it looks a bit janky. You literally have used a zip die. Whatever, I mean, it's probably what I would have done if I was doing it, so I can't complain to the manufacturer, but I would have just figured they had means to better objects. But what you can't beat with Pace, and also Metcal and a bunch of other providers do this, is what they put these things in, or they're this. I mean, this, I need to weigh this. I don't even know how much it is, but it's steel. This is steel, and that might be steel, or maybe that's just like a rough aluminum. Probably is aluminum. Maybe it's steel though. I don't know. And then they always do, and I think Metcal does the same thing. They compartmentalize, and Dave Jones commented on this. I noticed this with my other stands, is that, man, that is a tight space to shove a sponge into, but you get it in there eventually. And it does make for a nightmare of cleaning your stuff. Never, and I guess that's why they did it this way, is it was thought that it would keep it from building up in here, but no, you get all your stuff in there. And by stuff, I mean like your solder soot. You can see I haven't even really used this yet. I try to use as little water on the pad as possible, because it does actually, the water does increase your reactivity with your coating, your plating, and you end up shortening the life of that. So if I can get away without wiping it, I try not to. Really, the metal brush or copper brush, brass brush is all you need, but there are times where I can say there's some, some poop left behind on the soldering iron tip that having the wet pad would certainly take care of. And I just need to bring a bottle of distilled water in here so that I can constantly wet this. But one last thing to mention is the brush, the wool pad. Sorry, shouldn't say wool, it's not wool. It's all about the softness of this, and actually this is a brass. Copper would be better. Why? Because copper is a much softer metal. The softer it is, the longer your tip will last, because when you're pushing it in this and getting that solder off, you're rubbing it against something abrasive. Even copper is abrasive, but it is a much softer material than your tip, and that is the ideal behind these pads. And why brass is acceptable is that the plating that is on this tip, when you put it in and you give it a rub, this metal is metallurgically harder, more dense, or whatever the factor is there. I don't know, but it is harder. Its hardness scale is higher for the, what is the tip tinned with? Not iron, not copper is in the center, which we would love to have all copper tips. The problem is the copper being such a soft metal, your tip being all copper would actually be softer than your pad that you're cleaning with here. It would also be softer than any metals on the board other than copper itself. And that is where they run into a problem, where they're trying to make the difference. Nickel is the plating. So that nickel plating, you want to have a scoring surface for or an abrasive surface for cleaning your tip off that is softer than the plating. And that is where copper and brass rank softer than nickel. Hopefully that is all correct. You might want to fact check that. But I did some reading into tips and everything there where I started to get into, everybody says, why do they still use, the cheap steel or iron or whatever? Why don't they just make an all copper tip? And that is why. That is the answer, is that if your tip is all copper, it's just not going to hold up well. And so they try to create this balancing point between longevity and usability versus conductivity of its thermal energy. And yes, copper is the best thermal conductor, but it's super soft. So we find this balancing point. That's enough lecturing on tips and giving out what little information I do know about them. Again, there's probably people online that are way more qualified than I am. So you should go and watch their videos. But hopefully that gives you kind of some food for thought on tips and gives you an idea of how and where and what to search if you want to get a deeper understanding about it. And if I come across that write-up that I found again or if I come across it again on the write-up that I found about tips and their metal properties and why they make the choices that they make, I'll make sure to post that or a link to it in this video so that you can read it for yourself. Again, as always, if you have any questions, feel free to add those into the comments section. It is late. I want to be done, so I'm going to do this last part quickly. If you like this video and want to see more like it, go ahead and let me know in the comment section and click that subscribe button. If you want to get alerts, I think there's a different button that does that. I don't know. I'm not YouTube. I didn't build this shit. I just talk on it. So click, click, bloody click. All the buttons, whatever you need to do. Or if you don't want to see this video ever again, then don't click anything and you won't get reminders about new videos that are coming out shortly.